In this video, we will continue looking at common toxic materials by looking at ammonia and some others. So ammonia is another nitrogenous gas. Ammonia's chemical formula is NH3. And it's a colorless gas, but it has a very strong, pungent odor. And anyone who's worked with cleaning products knows the smell of ammonia. It is also used as a fertilizer. Anhydrous ammonia is very common in agriculture um, as a fertilizing agent, and we can also see it used in its anhydrous state as a coolant in large refrigeration systems. Um, we've talked about ammonia in the past. One of the things that we recognize and remember about ammonia is that it is a flammable gas. Now, it is not so flammable as to be considered a flammable gas by the Department of Transportation. It does not meet the requirements for that. However, it does have a significant range of flammability in areas that are relatively measurable, 16 to 25%. And we can find it generated at fire scenes in a couple of different ways. When we have materials that are manufactured from animal products, so we saw this with the nitrogenous gases, with the NOx gases in the previous video. Leather, animal hides, wool, hair-based products, those can generate, because they contain nitrogen, they can generate ammonia at the scene of a fire. And we also see that when we have fertilizers that contain ammonium compounds, so ammonium phosphate, ammonium nitrate, these are commonly found in nitrogen and excuse me, nitrogen-based fertilizers. And when those heat up, they will decompose to form ammonia as the ammonium breaks down into ammonia. And so ammonium ion is the NH4 plus ion, and it will decompose into ammonia, NH3, when heated. Now, when it comes to ammonia itself, the recommended practices are to basically establish a water curtain downwind from the point where it's being released. What this does is ammonia is very, very soluble in water. So washing it down like this will cause it to go back into solution. When it's volatilized, it's flammable. When it's dissolved in water, it's not. It is corrosive, but very mildly corrosive by comparison. Um, and so this practice is used to help contain it, which will help to slow the production of the ammonia down. Um, how does it impact us? How does it hurt us? Well, ammonia injures you through a couple of different mechanisms. First of all, at a negative 28 degrees Fahrenheit, we're getting into cryogenic material there, or at least close to cryogenic conditions there. It's very, very cold. We'll see a lot of the impacts that we commonly see with cryogens, freezing skin and other tissues, causing thermal burns and potentially other forms of skin damage. We can also see that when you breathe in ammonia, especially in high concentrations, you see ill effects from that as well. And so probably the place where most of us see anhydrous ammonia, if you work on a farm, if you live on a farm, which a lot of you do, a lot of us in this class have background or family backgrounds in agriculture, and this is probably the most common way that we see anhydrous ammonia. But notice the placarding here. It is an inhalation hazard. It is a potential cryogen, but your DOT placard here is green because it does not fall into the categories of being nearly toxic enough to get the black and white placard, and not nearly flammable enough to get the red placard. So green is the way to go. But you see these kinds of placard systems and labeling systems. These kinds of tanks are very, very common, especially in rural areas, agricultural areas, and so this is where we see a lot of the ammonia that gets used on a much larger scale basis than the small amount that's dissolved into a window cleaner or something like that. The next toxic material that we want to look at are carcinogens. Now, carcinogens, the word carcinogen is basically a cancer causing substance. So, carcinogens are substances that have known links to cancer. Now, they do so through a two-stage form of development. The first stage is the initiation stage, where your exposure to the carcinogen alters your genetic material, impacts your cells. And then there's a promotional stage. The promotional stage is when the damaged cell divides into new but also damaged cells as well. Those damaged cells can aggregate and form polyps. Polyps are just masses of tissue. Um, and inside of those polyps, as the promotion stage continues, we can see further mutations happening, especially if we have continued exposure to the carcinogen. And those polyps, which are benign, at least initially, can turn into malignant tumors, which are considerably more dangerous. Now, when it comes to carcinogens, there are three known groups. We have the known human carcinogens. These are the ones that have been studied, and the link between them and cancer causing substances is well established and known. We know that the substance causes cancer. There are the probable human carcinogens. These are the ones that we have a pretty solid evidence that there's a link between, but we're probably waiting on more information to fully move them up into that known group. And then there are the possible human carcinogens. And these are the ones that we don't have a knowledge. We suspect that there's a link. There isn't a whole lot of research to show that that link exists, but there's some data to suggest that perhaps a link exists, and we just need to do more research and more development to try to move it up the ladder if it indeed is carcinogenic. Now, how do we get exposed to carcinogens? Well, there are two ways. So your exposure can come in one of two ways. Either you are exposed to it through a commercial product. For those, notification on the product is required. You're probably familiar with this warning, the Prop 65 warning, which is a California resolution that says that all substances that are sold in California and have links to cancer, birth defects, or other reproductive harm, all of those have to be labeled with this warning. And so if you look on any consumer product, it seems nowadays, you'll find one of these warnings on it, especially if that substance has any kind of plastic on it whatsoever. So that's a something that you see very, very commonly is that Prop 65 tag. Now the other place where you can see these are workplaces, and it becomes the responsibility of the employer to provide info and protection if you are exposed to those kinds of substances, which brings on the why are there so many lawsuits about asbestos and mesothelioma and those kinds of things? Well, the point of those lawsuits is that the plaintiffs, the people who are suing, are making the claim that the employer should have known better and should have provided them appropriate ways to protect themselves. The last common toxic materials that we're going to look at are metallic compounds. Now, metallic substances are things that you do need. Um, you do need certain concentrations of metals in your body to perform essential functions of your body systems. However, most metals are toxic if we go above a certain threshold, a certain concentration, a certain dosage. And certain overdoses will just make you sick, others can outright kill you. And so, depending upon the concentration, depending upon the dose, that's really where we get off in uh, getting into trouble. Now, of these metallic compounds that have the high low dose toxicity, we tend to focus primarily on lead and mercury. And lead, this is probably the most common one that we can encounter. Where do we see it? Well, primarily we see lead in lead-based compounds. That is, paint pigments from lead-based paints. Back up until about 1975, we saw lead additives put into gasoline. And so lead would get dispersed in the air when that was burned um, in the form of smoke or dust. The problem with lead is it directly impacts your central nervous system. And so you see impacts of lead poisoning coming to the nervous system from those. In fact, it's an interesting story. There are many theories about why the Roman Empire ultimately fell. One of the interesting ones is the find in archaeological digs of lead-based pigments in pottery. So the ancient Romans and many ancient civilizations used ceramics to make cups and bowls and plates and things like that. And if you've ever taken an art class that did ceramics, you usually fire them with a glaze in the last step so that they get a little bit more durability, and it puts a coating on them that's a little bit harder and a little bit less resistant to cracking and chipping and whatnot. Well, there were some evidences that in the time of Nero, which is one of the last of the Roman emperors, um, that a lot of the materials that were used, they found evidence of lead in a number of their different pottery glazes and in a number of different of their ceramics. And so one of the theories behind why it fell and why Nero was kind of a crazy man, the most common story of him is playing his fiddle as Rome burned to the ground. Um, that craziness could have been the just barbaric nature of the society as it grew and ultimately spun into its demise. Another possibility is that they were dealing with some lead poisoning, and that the craziness that they were exhibiting was actually a response to the lead and the lead impact of their central nervous system. So, just kind of an interesting story and aside there. Now, where do we find lead and its relations? Lead acetate and phosphate are regarded as probable human carcinogens. So, in addition to the effect of the lead, we also get carcinogenic effects. And for these reasons, these were great pigments. Really produced some really vibrant kinds of colors. Um, but as a result, paints and other finishes, lacquers, and whatnot no longer are allowed to have lead-based compounds in them. Um, Now, unfortunate things, we've seen stories in the past 10 years or so where toys and other articles of consumer goods coming from other countries have been found to have lead-based paints in them. And those are obviously illegal in the United States. But because of the cheapness of the material, it is something that is certainly of considerable cause and pause to make you think about things that are coming in from overseas, especially cheap items. So that concludes our look at common toxic materials. We'll look at asbestos and other things in the last video of this series.